Hello. Uh, oops, sorry about this. Oh, okay. This is lab two. I'm Wendell Akers. So basically, the goal of this lab was to make a model showing the charge tapes from lab one and basically making the assumption that it's a line charge instead of a point charge because they'll obtain a different result in the end. Um, yeah, and for this one, we actually did obtain different magnitudes of excess charge. And it was the difference was around like 1.4 to the negative eighth. And the lab procedure was actually pretty much the same. I did everything that I did for the last one. I measured it out to be, or I measured it to point, 0.025 meters. Um, Pretty much, yeah, pretty much the same procedure from lab one. Just taking up the upper tape and the base tape and ripping them apart. And yeah. So for the assumptions and concepts, it's also going to be very similar to lab one, where since the top tape isn't moving, the forces in the y would be zero, so you can equal them together, equal all the forces together. And I'll show you that in a later slide. But Newton's third force, or sorry, third law, also comes into play because they are exerting an equal and opposite force on each other. So then you can find any unknown quantities by equaling them together. So these are the equations that I use and that I was talking about. So the electric force would equal the gravitational force since there is no movement of the top tape, so forces would equal zero. And you take these two equations and find the charge. And what's it called? What you do for a line charge is basically breaking up the tape and then calculating its net electric field with those small pieces of tape, those small parts you're looking at. And this is my Python code. I'm sorry if some of it's getting cut off a little, but yeah, this is basically what I did with a lot of help of the starting code. And yeah, this is basically everything that I did. You can't see, but the arrow scale is to like 1, 2, 3, 4, 5. It's 1 times 10 to the negative 5. And these are the models. I just put up lab one here so we could compare the different like visualizations of it because in the next or in the conclusion questions, I'm pretty sure they asked between the two. But yeah, these are what the glow script printed out or returned. Um, what if your model, what if you had modeled each of your tapes as a single point charge? Well, then, what's it called? You would have a significant difference because in this lab you modeled it as a line charge, and as I discussed earlier, the difference is this much. So there would be a significant difference just by the different ways you calculate it and the assumptions you make on the tape. Why do these estimates differ? And I sound like a broken record, but it's because of how the tape was like treated. It could be either treated as a point charge or a line charge, but they will both give you different answers because they're calculated in different ways. And but this one would be more real, calculating as a line charge because um, the result is more accurate of tape in real life because it would act as a line charge. Thank you.